Hello, and welcome to 5-Minute Math. Today we are looking at the 7th grade concept of describing pi. This is standard 7.5b in the great state of Texas. We are using item number 11 of the 2023 released STAAR test. If you haven't done so already, please go ahead and take a moment to pause the video, work this problem out on your own, unpause it, and we will look at our answers together. So we just need to describe pi. We need to find a definition that works for it. If we look at our reference materials, we come all the way down here. All we're going to get here is pi equals, and we've got this this equivalent here of 22 over 7 or 3.14. But you see their equivalent. We get some length, volume, capacity, weight, mass. We don't need any of that. And we do see that pi shows up here for the area of a circle. And we do see that pi is used here for circumference, right? Circumference equals 2 pi r, or c equals pi d. So we see pi in multiple spaces, but we need to be able to understand what it really is. Okay, so let's draw a circle, and let's pretend that's 100% circular. Okay, so we've got a center right here. So there's a few things that we can do with this circle, right? So we could draw a straight line from the center over to the side, and that's called the radius. We could also draw a straight line through the center from one side to the other, okay, and this is called the diameter. And then we could also measure, if we really wanted to, think of it like the perimeter, but it's not really the perimeter, right? It's called the circumference, but it's that same idea. It goes around. So we could measure all the way around. And then there's the inside, right? You could always just kind of look at the inside, and that's going to be your area, right? Square units, even though it's a circle. So those are the different things that we're used to at this point measuring on a circle. But here's where pi comes in, okay? So this is a Greek letter, and it is used in mathematics to represent a ratio or proportion. What mathematicians found centuries ago, thousands of years ago, is that no matter how big or small the circle is, as long as it is a perfect circle, right? We're going to get this right here. Let me open up my reference material. We see that c equals pi times the diameter, okay? So let me draw that right here. The circumference equals pi times the diameter. Well, if you use the properties of operations, what happens if you solve for pi? So since it's pi times diameter, I want to go ahead and divide both sides by the diameter. What mathematicians found a long time ago is that no matter how big or how small your circle got, so it could be as tiny as this, right? It could be as huge as this. It could be 30 times as big. There is this ratio. If you take the circumference and you divide it by the diameter, no matter how big or how small it is, it always ends up being this 3.1415. It goes on and on and on forever. It never stops. Or it's, about 22 over 7. It really doesn't matter how big or small the circle is. The circumference divided by the diameter is going to be about a little bit more than 3. Okay? So take a look. We have the ratio here, A, of the circumference to its diameter. Well, that's exactly what we're describing here. Pi is the ratio of the circumference over the diameter. So the ratio of the circumference to its radius, nope. It's the circumference to the diameter, so B is incorrect. The radius of the circle times 2 times 3.14, no. It would be kind of like area, but we don't multiply it by 2, we square it. And then the diameter of the circle, no, we're not doing that. So our answer here is A, because it's the ratio of the circumference of a circle to its diameter.